Next up, we can expand the stem and leaf graph by adding another column. This extra column we can add is what's called the frequency. In fact, let me copy all this to the next slide, because this is getting into the next slide. So what just happened is each row of our stem and leaf graph defines a class. The first row defines everything from 1.00 to 1.99. The second row defines everything from 2.00 to 2.99. And we keep going. So technically we have 9 classes, but we don't have any data for 3, 7, and 8. Within each class, if you count the number of data elements, that's called the frequency. So how many data elements start with a 1? 6. So the frequency for the first class is 6. How about the second class? 3. Next class? And same with the fourth class. Next. And then, good. If we added the frequencies, this should equal the total number of data elements that we've collected. What is 6 plus 3 plus 2 plus 2 plus 3 plus 1? Is it? I don't know. 1, 2, 3, 4, 5, 8. Yep, that's good. So there are 17 data items. So by adding the frequencies to this list, we have created what is called a frequency distribution. Frequency, the number of elements in each class. Distribution means, well, how do they lay out, basically. So we have 6 in the first class, 3 in the second class, so on and so forth. And again, since we don't have a stem of 3, what's its frequency? 0. So if we wanted to put 3, 7, and 8 in there, we wouldn't have anything in the leaf row, but then the frequency we would say 0. As far as relative frequency, what does it mean to be relative? How does it relate to, in this case, other classes? So how do they compare? Well, sad to say, probabilities comes back and says, hello. So basically, relative frequency says, if everything was equal, what's the chances that you pick an element from the first class or the second class or so on and so forth? It's really not that bad. It sounds scary, but it's not that bad. We'll just add another column here. We're going to say relative frequency. And this is the percentage or fraction of elements that fall within that class. Well, in the first class, there are 6 elements. The total number of elements is 17, so the relative frequency is 6/17. You can write it as a fraction. If you want to write it as a decimal, that's fine too, or a percentage. What's the relative frequency for the next class? 3/17. The next 2 classes each have a relative frequency of 2/17. Next one again is another 3/17. And we end up the show with 1/17. What is 6/17 plus 3/17 plus 2/17? 1. 17/17. So 100% or 1. That's fine. So the total frequency should add up to the number of elements in your data set. The relative frequency should always add up to 1 or 100%. Every time, otherwise something's not accounted for. So the first two columns are the stem and leaf. The third one is your frequency distribution. Your last one is your relative frequency distribution. We just happen to put it all together, which is fine. But notice by me saying 6, 3, 2, 2, 3, 1, we have now lost the actual elements. I have no idea how these 6 lay out in the ones. Are they 1.5, 1.3? Oh. So that's the bad thing when you start grouping things together. You lose individuality. Everyone starts wearing gray and buying iPhones. Thing. The next up is going to be a little more visual. We're now going to make a histogram and a relative frequency histogram.